Good afternoon. Now we have belt and pulleys. Now we will be looking at the first few examples of our belt and pulleys. So now the first question here, find the power transmitted by belt running over a pulley of 600 mm diameter at 200 RPM, revolutions per minute. And the coefficient of friction between the belt and the pulleys is 0.25 between the belt material and the pulley material. So you have a coefficient of friction of 0.25 and the angle of flap of 160 degree. And they have given us the maximum tension. The maximum belt tension is equals to 2,500 Newton. So this 2,500 Newton is actually the tension on the tight side. That is what we consider is T1. Okay, we have T1. So here you have a diagram showing you that the angle of flap, and then you have the tight side tension and the slack side tension. So given in the question, the diameter of the pulley, the diameter of one of the pulley is 600 mm, and the speed is 200 RPM. So you can convert speed here from revolutions per minute to radians per second. So by taking 2 pi n over 60, that is converting the minutes to seconds. So that is why you have to divide by 60. So you have seconds. And then revolutions is 200. We have 200 revolutions here, and each revolution is 2 pi. So that is why you multiply by 2 pi. So you have 2 pi n over 60, and you have converted it to 20.94 radians per second. And based on the speed here, we can find out actually the belt speed. Okay, the belt that is lapping over the pulley here. What is the speed? So you can use this. That is also the tangential speed, or we can call it as the belt speed, R omega. And the R here is the radius. So remember, given here, this one is the diameter. It's not the radius, and it is in millimeter. So if you want your unit to be in meter per second, remember the radius here. So that is 300 mm, must convert it to meter, that is 0.3. So and the omega is 20.94 radians per second. So you have 6.28 meter per second. And since that the speed here is less than 10 meter per second, so the TC is not taken into account. It's not taken into account unless if the speed here, the belt speed is greater than 10 meter per second, then you will have to take TC into account. That means the centripetal tension or the centrifugal tension. So and then the angle of lap, that is 160 degree, must convert it to radians. So you need to divide it by 180 times pi. So therefore, you get your angle of lap or the angle of lap as 2.79 radians. So once you have got the speed, the belt speed, and the angle of lap, and then they have given us the coefficient of friction and then the tight side tension, we can actually find out the slack side tension by taking the belt tension ratio. This is for flat belt without mass. So flat belt without mass, you have this formula. If with mass, you will have to take T1 minus TC over T2 minus TC. So this is without mass. That means you are not taking mass or the density of the belt material into account. So you don't have the TC. So here you have the slack side tension T2. So okay, so based on this, then you have T1 exponential negative mu theta. So you have to manipulate this so that you have T2 as the subject. So you have T1 exponential negative mu theta. So the T2, that is the slack side tension, you have 1244.57 Newton. So then you have power. So you know that the power is the effective tension multiplied by the belt speed and multiplied by the number of belts that it is used, okay, which is wrapping over both the pulley. Okay, so since the question does not mention the number of belts, so usually we take it as 1. So the power transmitted is 7884.1 watts. That is what the question asks. Find the power transmitted. That is your question 1, and this is quite easy. So now then the next question. Now a casting weighing 9 kilonewton hangs freely from a rope which makes 2.5 turns. Now 2.5 turns, that means if you were to convert it to number of revolutions based on 2.5 turns, it is, so you have to take the 2.5 multiplied by 2 pi. Okay, so and then the angle of wrap will be based on this 2.5 turns angle of wrap. That means how many times it is lapping over the pulley or wrapping the pulley. So you have to take 2.5 times 2 pi. So therefore you have 5 pi for the angle of wrap actually. Now round a drum, now not necessarily always a pulley, so you can use a drum also, of 300 mm diameter. So remember, this is again a diameter. Remember, okay, when we want to convert it to our belt speed, make sure this is in radius and in meter if you want it to be in meter per second. And then the speed is 20 RPM, revolutions per minute. So for revolutions per minute, you have to divide by 60 in order to convert it to seconds. Now, if it is RPS, remember, if given here is 20 RPS, that means revolutions per second. Then you don't need to divide it by 60, please. Okay? Now, the other end of the rope is pulled by a man. Now, the coefficient of friction is 0.25. Now, the question asks us to find the force required by the man to pull the whole thing up and the power to raise the casting. So given that this is 9 kilonewton, this should be the T1, not W here, okay? This should be the T1, okay? So that is the tight side tension. This is the number of turns. So you can convert this to theta. So you can see here, okay? So it is 5 pi. So it's 5 pi radians actually. So the radius based on this, the diameter is 300. So the radius is 150 millimeter. So this end here is something wrong. This is not the number of ropes or the number of belts. This should be the end here. This should be the theta, and this should be the uppercase letter N if we were to memorize the things by symbol. So if you are putting this like that, it doesn't matter unless, okay, as long as you remember what does that represent, okay? So the coefficient of friction is 0.25. Why I say so? Because you see all the symbols here, they are only symbols, okay? But we have to know, okay, each of the terms here, the given values here, what are they actually representing? Okay, so D1 is 300 millimeter, and then the speed, therefore you see, okay? So there is a slight mistake here. So N1 is 20 RPM. So omega 1 is 2 pi N1 over 60. So this is 20 over 60. So you have 2.094 radians per second. Again, for the belt speed, so this is the formula that you have seen most of the time in your dynamics. So this is V, belt speed, or when you refer to this formula, is actually referring to what we call a tangential speed. Or in our mechanical machines, we call it as belt speed. So radius is 0.15, okay, and the speed is 2.094 radians per second. That is what we have here. Okay, so you got a belt speed of 0.3141. Now, meter per second, again, is less than 10, so you don't have to take TC into account. Now, the angle of lap, so you see, they say, okay, the belt or the ropes has made 2.5 turns over the pulley. So the turns, okay, so 2.5 turns, so it is equals to actually 5 pi radians. So straight away, find out using your belt tension ratio, find out your T2, then the power. So this N here is not the N of this. This N here is actually the number of ropes. Here we are referring to ropes, so it is 1. Okay, so you don't have to take into account of cosecant beta over 2 here yet, because this is not a groove pulley. We haven't considered that part yet. But in actual case, if you are using a rope, then this must be cosecant beta over 2, because you will require a groove pulley for a rope in actual case. Now question 3. A belt lap a pulley by 140 degrees. So this is angle of wrap, again converted to radian, the first thing you must do. Now if the pulley diameter is 400 mm, so radius is 0.2 meter, And the coefficient of friction is 0.2. Calculate the power the belt will transmit without slip. This is slippage, okay? So when the pulley is rotating, now to improve or to reduce slippage, okay, actually we can use greater angle of wrap or greater angle of lap, or you can use either a V belt or a circular belt with groove, okay, with a pulley with groove, okay, so the slippage will be actually greatly reduced. Now, when the pulley is rotating at 350 RPM, and the maximum tension, this is T1. Okay, this should be T1. There is something wrong here. The data here is something wrong. Why there is a 9 kilonewton here? So T1 is 1200 Newton. Angle of lap is 140 degree. The radius is 200 mm, so 0.2 meter. Coefficient of friction is correct, 0.2. So we have to find out the power. So based on this, okay, so it is not always that you have to use, but then never mind. Okay, so 2 pi n, so that is 350 RPM divided by 60, so 350 RPM. So you have 36.65 radians per second. That is the angular speed, actually is the shaft or the pulley itself. So the belt speed, so it's 7.33 meter per second. So again, don't have to consider TC. So then you have the angle of lap or the angle of wrap. So given here is 140 degree. So 140 degree over 180 times pi. So you have angle of wrap of 2.44 radians. So belt tension ratio again, then T2 again, and then the power again. So this is another easy questions. So that is to start up with your tutorials. So basically, okay, we have to provide that is something simple at the beginning, okay, for your examples to understand how the things works. Okay, so the fourth example. Now here you go. Now an open belt drive connects two pulleys, 1.2 meter and 0.5 meter diameter on parallel shafts. Usually if you use open belt drive or cross belt drive, usually the driving shaft, sorry, this will be the driving shaft, and the driven shaft, actually they are placed parallel to each other. So next time I will draw another diagram showing how the shaft arrangement is when it is based on an open belt drive or a cross belt drive. And then they have given us both the pulley or the shaft, they are actually 4 meters apart. So from the center of this to the center of this, so you can see this distance here, oops, it should be 4 meters apart. So this is something wrong here, 1.2 meter. But then, okay, we can take it as 1.2 meters for an example. So you can just change this to 1.2 meter. Okay, this was my mistake, sorry. So the parallel shaft that is 4 meters apart instead of 1.2 meters apart. So you can change this question here, this to 1.2. Now the mass of belt is 0.9 kg. So you have the mass of belt here provided. It is 0.9 kg per meter length. Okay, and the maximum tension, that is your T1, should be 2000 Newton. The coefficient of friction is 0.3. And then the pulley, 1.2 meter pulley, which is the driver. So you have two pulleys here. One is 1.2 meter, the other one is 0.5 meter. So they have said 1.2 meter here is the driver. So that is why I put this as a driving pulley and this as a driven pulley. So this is actually working on speed reduction. Okay, or increase in speed, not speed reduction. Speed reduction should be the smaller drive, the larger. So increase in speed, improving the speed is larger to the smaller pulley. So when this one revolution, this will take 2 revolutions. If you are referring to a speed reduction, that means the smaller pulley should be the driver. So when the smaller pulley turns 2 revolutions, then the larger pulley turns 1 revolution. That is based on speed reduction. Okay. Now, the 1.2 meter pulley, which is the driver, runs at 200 RPM. So this should be the speed of the driving pulley. So I put it as N1. The radius 0.6 because the diameter is 1.2. Now, due to belt slip, okay, on one of the pulley, okay, the velocity of the driven shaft is, now the velocity of the driven shaft, that means this one here. Look at my laser pointer. So this is 450 RPM. So that means the driven smaller pulley is rotating at 450 RPM. Now calculate the torque on each of the two shafts, okay, the power transmitted and the power loss in friction. What is the efficiency of the drive? So here I have listed all the given datas, except this. Remember, I have changed this. Actually, it was my mistake. This should be 4 meter. Okay, but then you can just alter this value here to 1.2. So it will be based on a 1.2 meter distance instead of 4 meter. Okay, so you can rework this based on 4 meter later. So the speed 1 and the speed 2. So 1 subscript 1 usually I refers to as the driver, 2 as for the driven. So the driving speed is 20.94 radians per second, and the driven speed is 47.12 radians per second. Okay, so you have to look at my laser pointer in these cases here because I didn't actually animate the thing. Okay, so by looking at the laser pointer, you wouldn't know where I am actually referring now. Now, angle of lap. So the purpose of the questions given us the diameter of both the pulley and the center to center distance. The purpose is to find out the angle of wrap or the angle of lap. In this case, when you look at the question, they have not given us anything on an angle of lap or wrap. So you have this. So just substitute your radius and the center to center distance. If you are working on 4 meter apart, so this should be 4, please, class. Okay, so you have your theta, that is the angle of wrap of 162.31, and that is equivalent to 2.833 radians. Then again, from the belt tension ratio, now this far, all this while, we have only been looking at the belt tension ratio. So, okay, I think that is another mistake here that I've done. Okay, so I have I have taken this as no mass, but the mass is actually given. So you have to actually include TC here. Sorry, this was my mistake again. So I will correct this and then I will publish it again. So T1 minus TC over T2 minus TC equals to E mu theta. So your TC should be, in this case, your TC, listen very carefully. Now, because this, they have given us the mass. Okay, so I have not taken the mass into account. So this is my mistake again, another mistake. Sorry, very sorry. Okay, so TC should be equals to mv squared. M is the mass. V is the belt speed. So you have to work out the belt speed first. So mv squared. So TC equals to mv squared. You must put it here, T1 minus TC. First, you must work out belt speed. I'm explaining to you so you can do it on your own later on. Now, my mistake is I have ignored the mass of the belt. But in case like that, you have to consider mass of belt because they have given it to you. So you have to find out the TC. TC formula, that is a centripetal or the centrifugal tension formula. For this is mv squared. M is the mass, that is 0.9 kg over meter. That means per meter. Multiplied by the belt speed, which you should have found the belt speed here also as well. Okay, mv squared for the TC to be placed into the formula here. That is T1 minus TC over T2 minus TC equals to exponential mu theta. So you can find out the T2 taking TC into account. Okay, so you have to do some correction here, or you have to redo the question based on TC with TC and based on the center to center distance of 4 meter. So you will get another value of T2 and T1. So you can take this into account as without mass first. Then the next part you work out with mass. So then you compare. Okay, sorry. So belt speed. So I work out the belt speed, work out the power transmission. And then I work out the torque transmitted. Now, how I consider the torque transmitted? So let us take a look back at this pulley here, for example, the golden color pulley. Okay, so you have two sides with a belt. Okay, so actually you have T1 at one side. Now you see it is driving like this. So the top one should be T1 and the bottom one here should be T2. Okay, so to produce a torque, the torque on a pulley, so you must have tangential force multiplied by radius, remember. So the tangential force here is T1 multiplied by the radius here R2 or R1, up to you, okay? So here you will have T2, the other force that is multiplied by this radius, give you another, okay, torque. So based on one pulley itself, so you have a torque, okay, of T1 minus T2 times radius. So that is the torque based on pulley 1. That means based on this pulley. Then based on pulley 2, again you have T1 minus T2. Now both the T1 and T2 we have taken into account that they are similar. So the belt tension on both the pulley is similar. The only thing is the radius is different. So you can find out both the torque. One is on the driving torque and the other one is the driven torque. So then you can find the power input that is through the driving shaft. That means this is where your power input is and this is where your power output is. So you have this power input and this as your power output based on the torque. So you have to use this formula to find the power for this case for the pulley. Because pulley is a rotating component, so we use this, not the effective tensions times velocity. That is for the belt. So you have power input and power output. So if you want to find the efficiency, then you should take power output divided by power input times 100%. Okay? So that's all for this part, the work examples 1. Okay, I will continue with your work examples 2 afterward. Okay, and sorry for all the mistakes I made. Okay, if you like this video, please subscribe and like. Thank you very much.